I welcome everyone for today's session. Today, our session is about Earth movements and major landforms, geography. So, today we are going to discuss about major landforms, movements of the Earth. Movements of the Earth in the sense slow movement and sudden movements. So, landforms. First, let us see what are the landforms, different types of landforms. So, continents, mountains, plateau, plain, all that you would have heard. These are called landforms. Now, I have given here the earth is dynamic. It is not static, it is dynamic, it is moving. So, what is there under the earth? It is tectonic plates. Look at the picture. Tectonic plates, it's nothing but you can imagine like puzzle, jigsaw puzzle you play. You attach all the puzzle sets so that it gives a picture. Same way, under the ground, we can see tectonic plates. What are tectonic plates? The lithosphere is divided into several large and small irregular shaped plates. They are known as lithospheric plates or also known as tectonic plates. Okay. Now there are two types of movement, internal and external. Okay. Internal is happening from inside the ground, earth. It is also known as endogenic. External is it happens on the surface, outside force, exogenic movement. So example for endogenic is volcanic eruption. It happens from inside the ground, inside the earth. Earthquake and landslides. Erosion, that means external movement. Example is it happens because of the factors erosion, deposition by wind and water, that rain. These are the factors which makes external movements. Now we are going to see in detail about the internal movements and external movements. Okay, now tectonic plates is of two types, oceanic and continental. Oceanic is here given here, the plates on top and just below the ocean. Continental plates, they form the floor of continents where we live. They are located in the asthenosphere and in a state of constant motion. Okay, now there is something called Pangea, the supercontinent theory of continental drift. It was written by German meteorologist Alfred Wegener. Okay, it is believed by him that Pangea began to break out 200 million years ago. So here we learn there are two types of plates, oceanic plates and continental plates. Remember the difference. Now, formation of major landforms. I have listed major landforms here. In this we are going to see external and internal. This happens mountain external movement and from inside volcano. In detail we are going to see in this lesson. Slow movement of the earth causes continents, ocean beds, mountain, plateau, plains. These are known as exogenic. Exo means outside. Sudden movements. Sudden movements lead to volcanic activities and earthquakes. These are known as exogenic movements. It happens from inside the earth. Okay, now you see there are two types of plate movements. The arrow mark is shown here. First picture, the arrow mark, it's going away. Can we say it is taking diversion? So this effect is known as diverging plates. And in the second picture, they move together. They move in the same direction. It is called as converging. Okay, now see the definition. When the oceanic plates diverge means going away, what happens? Continents, ocean beds, basins are formed. When the plates converge is also, we can say it's colliding, hit each other, they lead to the formation of deep sea trench. You would have learned about trench. It's the deepest part of the ocean. Mariana Trench is the deepest part. Okay. Now diverging plates and converging, colliding each other. Now there is an important phenomena you should learn now. It is called convection current. Why does this converging, diverging happens? Because of the convection current. What is this convection current? It is nothing but the naturally what you would have seen, the hot air rises up. If we keep oil in the stove, when the water boils or oil when it is boiling, the hot air is automatically rising up. This tendency of hotter or lesser dense material to rise up is called as convection current. The same is happening from the asthenosphere. The hot air rises up, and this the plates converging or diverging happens. So geologists believe that when the convection current in the asthenosphere ascend means increasing, the lithosphere plates, it may diverge, that means going away from each other, or pull apart. Diverge, it's also we can say pulling apart. So something from inside comes outside. Okay, when there is a place formed, something it's newly formed. Okay, now see the next one, formation of mountains. How does the mountain form? There are two types of mountain. You can just work out this with your ID card. You just have your ID card in your two hands. Just give slight pressure at both ends. You can see the ID card is folding either to the upper side or to the lower side, upwards or downwards. So it is called folding. When you fold your ID card, just trying applying pressure, it is folded. So movement of lithospheric plates give rise to horizontal or orogenic movements. So there are two types of movement. One is folding. You can experience this with your ID card or quilling papers. Okay, so now I have shown here example of fold mountain. This is how the fold mountains are formed. In detail, we will study about this. The other one is fault. Fault is nothing but the crack. Crack is formed in between the lithospheric plates. So either the part is subsided, going down, or sometimes it comes up. This is what is called as fault. There is a crack. So this is an example of fault mountain. This is an example of fold mountain. Now in detail about fold mountain. When the fold mountain is formed, it may be anticlines or synclines. Anticline is nothing but up upward movement, upward folding, or syncline is downward folding. So what is folding? It is wrinkling of rock layers of the earth's crust, which is referred as folding basically. It's of two types: anticlines, also known as ridges; synclines, it's also known as valleys. Okay, anticline and syncline, it's shown here. And ridges are of two types: old fold and young fold. The name itself suggests old. It depends upon the age, before how many years it is formed. That is how we classify the ridges, anticlines, into two types: old fold and young fold. Now see, old fold mountains first. Old in the sense it is very old, formed before 100 million years before. So it is lesser in height compared to young fold. Why it is? We can have a comparison like this. Elderly people, maybe after 90 years, the people normally start bending, right? The backbone bends. So remember like this, the old fold mountains are lesser in height because it is exposed to the outside weather conditions, factors, and old fold mountains are lesser in height. Example, Appalachians in US, Aravalli ranges in Rajasthan. Okay, now about what about young fold mountains? Young fold is taller comparing old fold. It is formed less than 100 million years. It has sharp peak. Okay, so why it is like this? The horizontal plate movements that are pushing them higher even today. That movement is still happening, so it grows higher. Okay, example is Himalayas. Himalayas is example for young fold mountain. Okay, now the difference between old fold and young fold. The old fold has round peaks and gradual slopes. They are lesser in height. It is formed before 100 million years ago. Young fold has pointed peaks and steep valleys, taller than old fold mountains, formed less than 100 million years ago. These are the major difference between old fold and young fold. What is fault? Faulting means there is a crack. Okay, it is not a small crack. Large scale displacement. Okay, when the lithospheric plates move, stress and strain make fractures. Fractures in the sense the bone moves, right? So large scale displacement of rocks, it is known as faulting. Okay, that is what is called as faulting. Now, two types of faulting. When the part is uplifted, it is known as horst, 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 or also known as block mountain. When the part is subsided, when some part is going down, it is called as graben, pulling down. Grabbing means pulling down, also known as rift valley. Okay, now there are three types in which fault mountains are formed. One is normal fault, reverse fault, tear fault. Normal fault, I mentioned here. See the subsided part, it comes down. Okay, reverse fault is shown here, and tear fault, it is lateral. It happens in the side. See the way it moves, lateral movement. Three types of fault movement: normal, reverse, and tear faulting. Okay, now this is about internal movement, endogenic force. Sudden movement happens from underground the earth. That is what is called as earthquake. Earthquake is caused because the sudden displacement of lithospheric plates. Okay, so the displacement produce vibrations or tremors. What is vibration? You can imagine, see the picture. When we throw a small stone into the pond, the vibration is reached to the sides, okay, in the concentric circle manner. So according to the weight of the stone, the vibration reaches. That is what is called as tremors, vibration. Now you see, what is focus? The point or place of origin of an earthquake under the surface of the earth. From there it starts. Focus is a point from where the earthquake starts. That is the origin. What is epicenter? Straight opposite, vertically opposite, located on the surface of the earth. We name this place as epicenter. The vibration is spread it till here. Tremors. Vibrations or tremors spread out in all directions. Okay. Now these are known as seismic waves. We mentioned vibrations, that is known as seismic waves. That travel in all directions, referred as seismic vibrations. How do we measure earthquake? It was not a standard one previously. There is a American seismologist, Charles Francis Richter. He invented a standard way of measuring magnitude of earthquake. It is called as Richter scale. We are following that only now. What is scale? The scale used using which we measure the intensity of the earthquake waves. Okay, now there are two types of scales. Markali scale, it was not standard and it was giving approximate measurements. And now we use Richter scale, which is considered as an accurate scale. And there are two concepts, two things you should know. Seismology is a study of earthquake waves, and seismologists are scientists who study about earthquake waves. And how do we measure earthquake? Nowadays, we use Richter scale to measure it. If the Richter scale shows magnitude from 0 to 6, it is considered as mild. And when it shows more than 6, it is considered as major earthquake and it causes lots of destructions. In 2010, we experienced a major earthquake. What are the causes of earthquake? For the mild earthquake to happen, the reason is human activities, drilling, blasting, bomb blast, etc. Major earthquake can be caused by volcanic eruption, faulting, and landslides. Okay, now volcano. Volcano is defined as a vent. Vent means the hole or an opening in the crust of the earth, which allows hot molten magma to escape from below the surface of the earth, like pressure cooker burst. Okay, on the basis of the frequency means when it erupted at last. On according to that, we divide volcanoes into three types. One is active volcano, anytime it will erupt. Dormant volcano, it is called a sleeping volcano, means for past few years it didn't erupt. Okay, but anytime it may erupt. That is why it is called as dormant volcano. Extinct volcano, it is called as dead volcano. That means it shows the signs of volcano, but it has never erupted. So it is called as dead volcano. And there are many advantages, significance of volcanoes. It serves as popular tourist attraction and it brings out the minerals from the interior of the earth, which comes out as magma, which comes out as lava. It helps to increase the fertility of the soil. These are the importance of volcanoes. Thank you, children.